All right, so now we are going to expand our computational skills into loops with our physics class. So GlowScript uses the while loop, and the while loop is a way to repeat an operation over and over and over again. Okay, so there's a specific operation that happens either for a certain amount of time or forever and ever. So it just keeps repeating that process over and over. So for example, if your job is to stack wood into piles of 100 logs, you would be going through a loop, right? So you would pick up the log, put it in a pile, add one to your mental counter, and if it's not 100, you're going to go do that again. Okay. Now, you keep doing that over and over and over until you have the right number of logs, right? So if you only have 3 logs in your pile, you're going to go back to the top of your list, you're going to pick up another one, put it in the pile. Now you have 4, all right? We're not to 100 yet, so we're going to go back, we're going to pick up another one. Once you get to 100, then you move on. And we're going to go take a nap because that was exhausting. So now this is not an actual code in Python, so don't type this into GlowScript and expect it to do anything. But this is kind of what this would look like, right? So up here at the top, we have the number of logs. This is our variable, and this is what we're counting. So we're going to count our counter at 0 because we don't have any logs in our pile yet. The while statement is the conditions. So how long does this loop run? Well, we want 100 logs in our pile, so while the number of logs is less than 100, we're going to keep adding to our pile. So we're going to do another loop every time that we look at the number of logs in our pile and it's less than 100. So if it is less than 100, we're going to pick up a log. And then we're going to place that log into a pile. Right? So that is what we're actually doing. We're picking it up, putting it where we want it. And then this is our mental counter. All right, so we've picked one up, we put it in the pile. Now we have 1 log instead of 0. We come back to this while, okay, that's less than 100. So we're going to pick up our log, place it in a pile, add it to our counter, go back to the top. So we're just going to keep repeating that over and over and over until this second line isn't true anymore. Okay. So this program now goes back up to the top of the loop and compares it to the number of the logs in the counter. So now our logs is 1. So this loop is going to keep repeating. Okay, so as long as the number of logs in our counter is less than 100, it's going to continue through this loop. Now, if we get to this point where the logs does equal 100, so we've put 100 logs into our pile, when we get to that second point there where it says while logs is less than 100, well, okay, so now it's not less than 100, so we're going to skip the loop and we're going to go take a nap. Okay, so as long as that second line isn't true, it's going to continue the loop. So you're going to start a new program. We're going to call it loops. We're going to do a really simple loop. So pause this and put this into your GlowScript with that particular piece of information in a new program in your folder. Make sure it is a public one so that I can see it. All right, so here's the program that we're going to run. Okay, type this in, but don't run it yet. I guess you can run it. We'll kind of look and see what happens here. Okay, we're going to go over this. So in your loops program, type in this information. Okay, so if we look at this, this is our variable, right? We have this x variable up here at the top, and our x variable at the beginning is 0. So we're starting with 0 x's, whatever those x's happen to be. In this case, it's going to be numbers, but it could be a different object or something in your program as well. Now, if we look inside of our while loop, what we're going to do is we are going to add 1 to our x variable. Now, be careful here. This is not algebra. Okay, so x does not equal x plus 1. What this is the program saying our variable x, which right now is 0, we are going to add to 1. Okay, so it's not a math problem, but it's a command to the computer. So there is a slight difference there. So while x is less than 21, we are going to add 1 to our x variable. Okay, so if we take x equals 0, we're going to add x plus 1, and that is definitely less than 21. That will be 1. So we're going to continue with our loop. We're going to add 1 again, which will be 2, which is less than 21. So we'll add 1 again, and we'll just keep doing that until x is less than 21. So how long does this loop run? What are we going to count to? Think about that number for a second. As soon as x is not less than 21, then we're going to stop our loop. At the same time, we're going to print. Remember this print command? The print command is something that prints something on your screen. So after we add 1 to our variable, we're going to print x equals whatever x is equal to. So in this case, right now it's 0. We run the loop, we're going to add 1, so it should print x equals 1. And we're going to run the loop, it's going to add it to 1, and so then we're going to have x equals 2. So we should see on our screen x equals 1, x equals 2, x equals 3. So the last number that you see on the screen should be x equals 20, okay, because that's the only number less than 21 when we add those together. So once we get to 20, then we are going to be completely done. It's going to skip the loop and go to the next command, which is print all done. Okay. And then think about this. What's this rate? Rate is how fast we're going to count. Okay. Oops. So run this program and see what happens. And then go back and change some of those numbers. Change the rate. See what happens. Change the 1 and the x plus 1. Change the x is less than 21. Change those a little bit and see what happens with your program. Because then you have a challenge. You have to turn in 1. You can turn in all 3 if you want. But you're going to add this to the bottom of your loop. So you'll have both of them, so you have one to compare it to. So don't delete the one that you just typed in. Just go down below. You're going to have two loops going. Okay. So count to 50 in 10 seconds. Think about what you're going to have to change there. Okay. Count backwards from 100 to 0. Or you can count to 1,000 by 5s. Okay, so you have 3 different things that you can turn in as an assignment for your challenge. You can do all 3, but you only have to do 1. When you're finished, turn this into Classroom. Add it to a link. Remember, make this public. Go in and copy and paste your link as a link in Classroom on the assignments page. Okay, so now we are going to make our ball move. Okay, we're going to expand on this a little bit. So in physics, when we say something is moving, what we really mean is that object is changing its position, right? So this can actually be put in as a loop. So to talk about how far the ball moves, we need to specify its velocity and how much time has elapsed. So start a new program called Moving Ball. Put in your usual header up there at the top. And then create a sphere. Okay, you can make it whatever color you want. Keep it at 0, 0, 0. So don't change in a position just yet. For right now, just make a simple sphere. We'll go back in and change those properties here in a little bit. Okay, so when you move the ball, you are actually updating the position of the object. And this is called velocity, right? The change in position of something is its displacement. If we do it over time, then it's the velocity. So we are going to make the velocity an attribute of the ball. Okay, it's a property of the ball. So the fact that that ball is moving, that's a property of it. So we're going to change some things a little bit here. If we look at this, we have our ball. It's a red one. On line 10, ball.velocity is assigning that ball a velocity. Now remember, velocity is a vector. The vectors are the same in velocity as they are for position or rotation or anything else. We have x, y, z. So on line 10, we are saying that the ball, which is our red sphere, has a velocity that is equal to 1 in the x direction. Okay, so we'll look at what that exactly means here in a second. So assign that attribute to your ball. When you move the ball, again, you are updating the position, okay? So think about, back to class, how do you find the new position of an object? Okay. Velocity is displacement divided by time. So displacement is what we're looking at. Our change in x is equal to the velocity times the time. So in our program, what we're going to do is we are going to change our position using the velocity of our ball in a certain amount of time. Now, your computer doesn't speak Greek, okay, so we can't use delta. We're going to change this to make it a little bit more specific in our loop, okay? Remember that delta x, delta means a change in. So delta x is that final minus the initial. So my final position minus my initial position, where I ended up compared to where I started, is that change in position. So we're going to put that into our equation. So instead of delta x, we're going to have final minus initial equals vt. And once more, since we're talking about specifically the position of the ball, we're going to rearrange that. Okay, so our final position is equal to our initial position plus our velocity times time. Okay, so this is our kinematics equation. This is our big equation. It looks a little bit scary, but we're going to translate this into computer speak. Okay, so because if we put this in here, our computer doesn't know what that means. So don't put this into your program yet. We'll come back to this. But here's what this means. The position of the ball is at xf, right? Where our ball is now is our final position. That is equal to the initial position of the ball plus the velocity of the ball times the time that it takes for the ball to go that far, okay? So y dt, what do you think that d means? D is actually delta, and we need to define it. So delta is our time period. So remember when we did our lab with our constant velocity, we had a time period of 1 second. What was happening every second was our delta t. So we want to define a change in time period here. So let's just use dt equals 0.2. Okay, we'll start with that and change it later if we want to. And we are going to start at time 0. All right, so now we have all of our initial properties. We have a ball. Okay, we've named our sphere ball, and it has a color red. We have given the ball a velocity that is moving in the x direction at a rate of 1, whatever that means for us right now. We have a time period of 0.2, and we're going to start at time 0. Now we're going to create our while loop. Okay, so we're going to go for less than 10 seconds. So when this turns to 10 seconds, then we'll stop. So while time is less than 10, okay, so as long as our time does not equal 10, the ball position is going to equal the ball position plus the ball velocity times the time. Okay, so we're going to be updating our position every 0.2 time periods by however fast our ball is moving. Okay. And then we are also at the same time going to update our time. Okay, so we have two things that are changing here. So think back to our position time graphs, right? So over time, we have a change in time. We also have a change in position. So we have two things that are changing in our loop. Okay, the first one is the ball position, and it's going to move according to our velocity equation. And then the second one is our time, and it's going to move according to the time period that we set. Okay, so as long as t is less than 10, our ball position is going to change at that rate. Okay, so type that in, see what happens. All right, so here's your assignment. You're going to create a scene that includes at least a ground and two objects racing across the ground. That means each object is going to have a different velocity. So there has to be a clear winner, and each object should be a different color. And they should both stop at the end of the ground. So the end of the ground is the winner of the race. So create a race between two objects. They can be spheres, they can be pyramids, they can be people if you can figure that out. But there should be a clear winner, and they should both stop at the finish line. To make it interesting, create a commentary. So print some things down at the bottom as that's going on.